All right, diving in today, ready to explore something pretty fascinating, I think. Deep hip rotator muscles. You with me?
Absolutely, yeah. These muscles, they're like a secret engine driving so much of how we move.
Hmm.
And most people, I'd say, probably don't even know they exist.
Right. Totally under the radar, but crucial. We've got some awesome research articles and anatomy studies here, and I'm thinking, let's pull out the nuggets, the real gems about how these muscles impact our posture and our movement. But you know, in a way that doesn't feel like we're back in anatomy class, right?
Yeah, totally. No textbooks here. We're aiming for clear and fun and hopefully some aha moments along the way. We
Yeah.
look at the anatomy, how they actually work, the nerve stuff, and then the biomechanics. Even how these little muscles might be connected to, what's that Japanese term? Yugami, body misalignment.
It's YUGAMI. Okay, so before we get ahead of ourselves, let's back up. Who are the players on this deep hip rotator team?
Okay, so we've got a team of 6. Jot these down if you're taking notes. Piriformis, obturator internus, superior gemellus, inferior gemellus, quadratus femoris, and obturator externus. That's our starting lineup.
Okay, wow, that's quite a roster. So maybe we could start with just one to get a feel for where they are and what they're doing back there. Like, what about that obturator internus?
Sure, yeah, good one. So picture your pelvis, right? And on the inside, there's this big opening called the obturator foramen.
Mm-hmm.
Like, imagine it's a window in your pelvic bone. The obturator internus attaches around that opening and also to a tough sheet of tissue called the obturator membrane.
Okay, so it's on the inside of the pelvis. Then what?
Well, it kind of does this cool thing. It actually goes through another smaller opening called the lesser sciatic foramen, kind of sneaks out of the pelvis. And then its tendon, the strong cord-like part, finally attaches to the greater trochanter, that bony bump you feel on the outside of your hip.
It's taking a detour out of the pelvis. Wild. All right, and then there are the gemelli, right? They always sound kind of like a dynamic duo to me.
Totally. They're like best buddies with that obturator internus tendon we were talking about. Superior gemellus, it starts at your ischial spine. That's like a pointy part of your pelvic bone.
Yeah.
And it attaches right onto the obturator internus tendon.
Okay, so it's on top of the tendon.
Right. And then the inferior gemellus, it starts lower down on the ischial tuberosity, that part you sit on. And guess what? It also joins the obturator internus tendon party. So they're both kind of hugging that tendon above and below.
Teamwork makes the dream work, as they say. I've even heard them called, all together with the obturator internus, the triceps coxae.
Yeah, exactly. Triceps coxae, which basically translates to like the three-headed muscle of the hip. And that really captures how they're working together, these three, to control that hip rotation.
Okay, this is already blowing my mind, and we're just getting started. Question though, does everyone's anatomy look exactly like this? Like, are there variations?
That's what's so cool about anatomy. There's always these little variations. It's not like a cookie cutter thing.
Really? Like,
Well, for instance, there have been cases, documented cases, where people are missing both gemelli muscles on both sides, just not there.
wow, really? No gemelli at all?
Nope. And then even when they are there, the exact spots where they attach, those can be different too. Sometimes the superior gemellus has like 2 separate starting points, or the inferior gemellus, instead of being neatly tucked in, it might spread out more, even go a little bit inside the pelvic cavity.
Wow, fascinating. So even at the most basic level, there's this beautiful variation. Makes you realize how unique everyone's body is.
Okay, so we've got the gemelli buddies and the obturator internus. What about the piriformis? Isn't that a key rotator too?
Yeah, piriformis, another big player in the deep rotator game. And here's a little fun fact. Sometimes its tendon actually blends in with the obturator internus tendon, like they literally become one. Shows you how closely they're working together.
Huh, cool. And just to remind myself, all these muscles we're talking about, they're deep, right? Like
Yeah.
under the big gluteus maximus muscle. Exactly. That's why they're called the deep rotators. The glute max is like the showman, the one you see. But underneath, these guys were quietly working. And importantly, they're all hanging out pretty close to the sciatic nerve. Remember that because it'll come up later, and it's a big deal.
Ooh, foreshadowing. I like it. Okay, so we know who they are, where they live, but what's their job description? What are they actually doing in there in terms of like the physiology and biomechanics?
Okay, well, first and foremost, they're external rotators. That's their main gig. So think about turning your foot outward. They're the ones doing that.
Uh-huh.
They also help with hip extension, especially when your hip is bent.
So they're turning the leg out and helping to straighten it back.
Yep. And here's another cool thing. When your hip is flexed, like when you bring your knee up towards your chest, these same muscles also help with abduction. That's moving your leg away from the midline of your body.
So depending on the position of the hip, they're multitasking.
Exactly. They're versatile little muscles. But beyond those movements, they have another, maybe even more crucial role. They're stabilizers.
Ah, right, the stability thing. I remember reading about that.
Yeah, it's huge. Think of them like the rotator cuff muscles. But for your hip, they're constantly working to keep that head of your femur, that ball at the top of your thigh bone, perfectly centered in the acetabulum, that socket in your pelvis. So as you're moving, they're fine-tuning everything, making sure the
Mhm.
joint is secure and stable.
So, like, even though they're not the big, powerful muscles that make us jump and run, they're constantly working behind the scenes to keep everything in alignment.
Exactly. And, if you look at the physiological cross-sectional area, the PCSA, of each of these muscles individually, they're actually quite small.
PCSA, that's the measure of how much force a muscle can generate, right?
Yeah, exactly. And so looking at them one by one, you might think, oh, these are tiny. They can't be doing that much.
But there's a but coming.
Always a but in anatomy, right? But when you group the gemelli and the obturators together as that functional unit, like we talked about, their combined PCSA becomes way more significant. In fact, it can be even larger than the gluteus minimus, which is another important hip muscle.
Wow, that is surprising. So they are small, but together they pack a punch.
Absolutely. It's like their strength lies in their unity.
Hmm.
And it tells us that their primary role is really about stability, fine-tuning, rather than big, powerful movements.
Mm.
So don't underestimate those little muscles. They're essential for keeping your hip healthy.
I'm definitely not underestimating them anymore. Okay, so we've got the rotation, the stabilization. Is there anything else about like the actual structure of these muscles that makes them such good stabilizers?
Yeah, so think about the muscle fibers themselves. These guys have pretty short muscle fibers and very small pennation angles.
Pennation angles. Refresh my memory on that one.
Sure, so pennation angle is basically the angle at which those muscle fibers are attaching to the tendon. And a small angle, like we see in these deep rotators, means that the force those fibers generate is going almost directly along the axis of rotation. So it's super efficient for control, for making tiny adjustments.
Like no wasted energy, everything is focused.
Exactly. And another thing, they're located really close to the hip's axis of rotation. That means their length doesn't change much, regardless of whether your hip is flexed, extended, abducted, whatever. They can exert that fine control all the time.
Huh. So position doesn't matter, they're always ready to stabilize. Okay, so now let's get into the brain stuff. How are these muscles controlled? What's the neuroscience behind it all?
Okay, so each of these muscles gets its marching orders from a specific nerve, and they all originate from the sacral plexus. That's a bundle of nerves in your lower back and pelvis.
The sacral plexus, that sounds vaguely familiar.
Yeah, it's like nerve central for your lower body. So the obturator internus gets its signal from the nerve to obturator internus, which comes from the L5, S1, and S2 nerve roots.
Okay, hold up. What does L5, S1, S2 mean?
Oh, right. Those are basically levels in your spine where the nerves come out. So L5 is the fifth lumbar vertebra, and S1 and S2 are the first and second sacral vertebrae. It's just a way of identifying where the nerve is coming from.
Gotcha. So the obturator internus gets signals from those three levels. What about the gemelli?
Okay, so the superior gemellus is interesting because it usually gets signals from two different nerves. It gets input from the nerve to obturator internus, which we just talked about, and also from the nerve to quadratus femoris.
Wait, it gets signals from two nerves? Why would that be?
It's not totally clear. It might be a developmental thing, like maybe they evolved from separate muscles that kind of fused together later on, but kept some of their original nerve connections.
Fascinating. So it's like a two-for-one deal nerve-wise.
Yeah, kind of. Although, to be honest, the exact prevalence of that dual innervation, it can vary a bit depending on which study you look at. Anatomy is always keeping us on our toes.
Always keeping us guessing. Okay, so superior gemellus can have two nerves. What about the inferior gemellus?
Inferior gemellus mostly gets its signals from the nerve to quadratus femoris, the L4, L5, and S1 nerve roots. But it can sometimes also get some input from the nerve to obturator internus. So a little bit of overlap there.
Gotcha. And the other two muscles, the obturator externus and the quadratus femoris.
Okay, so obturator externus, it's innervated by the obturator nerve. That comes from L3 and L4. And then quadratus femoris, it gets its signal from the nerve to quadratus femoris, the same one that goes to the inferior gemellus.
Right, some shared nerve territory there. And I think I read somewhere that the nerve to quadratus femoris comes from higher up in the sacral plexus than the nerve to obturator internus.
Exactly. So the nerve to quadratus femoris tends to come from those upper or more cranial segments of the sacral plexus compared to the obturator internus nerve. And there's actually some interesting stuff going on with these nerves.
Like what?
Well, some studies have found actual communication, like connections, between the branches of these nerves, both inside the muscles and in the surrounding tissues. It might be like leftover from their development, or maybe it gives them some backup in case one nerve pathway gets messed up.
Wow, so there's like a secret network of communication going on between these nerves. That's amazing.
And just a quick point about those nerves, like the nerve to obturator internus and the gemelli,
Yeah.
they have to exit the pelvis somehow, right?
Right, they can't just stay in there forever, so where do they go?
Well, they exit through the greater sciatic foramen. And specifically, they pass below the piriformis muscle, which creates this space called the infrapiriform foramen.
The infrapiriform foramen. I'm gonna have to write that one down. Okay, so they're squeezing through this little tunnel under the piriformis muscle.
Yep. And that's important because, well, we'll talk about it later, but things can get a little crowded in there.
Okay, more foreshadowing. I can't wait. So we've covered the nerves. What about reflexes? Do these deep rotators play a role in those, automatic movements our body does?
Oh, yeah, definitely. Like all skeletal muscles, they're involved in the stretch reflex. You know, if you tap your knee, your leg kicks out.
The classic knee-jerk reflex.
Right. So these deep rotators have these little sensors called muscle spindles inside them, and they're constantly monitoring how much the muscle is stretched. If a deep rotator gets stretched too quickly, those spindles send a signal to the spinal cord, and boom, the muscle contracts to protect itself.
So it's a built-in safety mechanism, like don't stretch me too fast.
Exactly. But the thing is, if those muscles get really tight or hypertonic, that reflex can become too sensitive, and it can actually limit your range of motion.
So tightness in those muscles could make us less flexible.
Huh, interesting.
Hmm.
And what about just standing still? Do these muscles play a role in keeping us upright even when we're not moving? Totally. They're part of this amazing system of postural reflexes. Think of it like this. Your body is constantly getting information from your inner ear, your eyes, and these sensors in your muscles and joints called proprioceptors.
Proprioceptors, those tell us where our body parts are in space. Right?
Exactly. And based on all that information, the deep rotators are making tiny, unconscious adjustments all the time to keep your pelvis level and your posture aligned.
Wow, so even when we're standing still, they're working hard to keep us balanced.
Absolutely. But here's the thing. If those muscles are imbalanced, like if one side is tighter or weaker than the other, it can throw off the alignment of your pelvis, even a little bit.
And that brings us back to YUGAMI, right? Body misalignment.
Yes, it's all connected.
Yeah.
Because if those deep rotators are messed up, it can directly lead to pelvic instability and abnormal rotation.
Okay.
And your pelvis is like the foundation for your spine. So if the foundation's off, everything above it can get wonky too.
So, like, tight, deep hip muscles could pull the pelvis out of whack, and that messes up the spine. Makes sense.
Exactly. And it doesn't stop there. That misalignment can even affect your knees and ankles. Think of it like a chain reaction.
A chain reaction of misalignment. Ouch.
Yeah, it's not good. And our sources don't go into, like, the super specific details of how it impacts the knees and ankles, but it makes sense that it would because the whole body is connected.
Right. It's all one system, so it all starts with those deep rotators, potentially.
Essentially, yeah. And even if it doesn't lead to full-blown yugami, tightness or weakness in those muscles can force other muscles to compensate. And that can lead to pain and strain in other areas.
So even on their own, these muscles can cause problems. It's not just about the knock-on effects.
Right. They can be a source of pain themselves. You probably heard of piriformis syndrome, right?
Yeah, that's when the piriformis muscle irritates the sciatic nerve.
Exactly. But the other deep rotators can cause problems too. Athletes, especially ones who do a lot of kicking or quick changes of direction, they can get obturator internus strains. And that can be a sudden injury or something that builds up over time.
Ouch. Not fun.
Definitely not. And then there's the gemelli muscles. Those can get strained too. There was even a case study of a guy who got an inferior gemellus strain with a hematoma after playing basketball. Pretty rare, but it shows you that those muscles aren't invincible.
And we can't forget about that sciatic nerve, right? That seems like a key player in all of this.
Absolutely.
Yeah.
The sciatic nerve is that big nerve that runs down the back of your leg, and it passes right by the gemelli and obturator internus muscles. So if those muscles get tight or go into spasm, they can actually compress the nerve.
And that's what causes sciatica, right? That shooting pain down the leg.
Yeah, exactly. It's called deep gluteal syndrome, when the nerve gets trapped in that deep space. And it's not just about compression either. There's actually connective tissue that links the sciatic nerve to the gemelli obturator complex. So when your hip rotates, That nerve has to bend and stretch a bit, and the tightness of those deep muscles can make that worse.
Wow, it's amazing how much impact these small muscles can have on the whole system.
It really is.
Yeah.
And, even surgeons have to be super careful about these muscles when they're operating around the hip
Really?
because those muscles are so close to important structures, like the sciatic nerve and the medial circumflex of femoral artery,
Mm.
which supplies blood to the hip. So if the surgeon isn't careful, they could damage those muscles, which could mess up the stability of the hip after surgery and make recovery harder.
So they're small, but they're definitely not insignificant. It sounds like we need to start paying more attention to these deep rotators.
Absolutely. I mean, think about it.
Yeah.
If you got any aches or pains in your lower body, those deep rotators might be contributing to it, even if you don't realize it. It's worth exploring.
Wow. Okay. I think we've officially done a deep dive here. Can we just recap, like, the main takeaways?
Yeah, so bottom line, the deep hip rotators, team of 6, deep in your hip. They do external rotation of the leg, but their main job is stability, keeping that hip joint happy and healthy. They've got their own special nerve supply, and their anatomy can be a bit quirky, but they're all working together. And when they're not functioning right, it can cause pain, sciatica, even contribute to YUGAMI.
Amazing. I feel like I've learned so much today. I know I'm going to be paying more attention to my deep rotators from now on.
Me too. And, for our listeners out there, if you want to keep those deep rotators happy, there are things you can do. Exercises for hip stability are a great place to start. Lots of physical therapy and yoga practices focus on that.
Right. And if you're having any persistent pain, definitely see a physical therapist who specializes in this area. They can assess your specific situation and give you personalized advice.
Exactly. Don't ignore those aches and pains. They might be trying to tell you something.
Great advice. Well, thank you so much for taking this deep dive with me. It's been enlightening.
My pleasure. Always happy to geek out about anatomy.
And to our listeners, thank you for joining us on this deep dive. We'll see you next time.